everyone, my name is Lucky Chidupali, and today I will be showing you some SAT math practice problems in the calculator section. So for our first problem, we have a retail company has 50 large stores located in different areas throughout the state. A researcher from the company believes that employee job satisfaction varies greatly from store to store. Which of the following sampling methods is most appropriate to estimate the proportion of all employees of the company who are satisfied with their job? So we have A, selecting one of the 50 stores at random and then surveying each employee at the store. B, selecting 10 employees from each store at random and then surveying each employee selected. And 3 is surveying the 25 highest paid employees and the 25 lowest paid employees. And D, creating a website on which employees can express their opinions and then using the first 50 responses. The best method for getting the most effective or widespread results when doing sampling would always be to take people at random, because you will get a more varied answer and it's not from a particular group of people. For example, in option A, we see that selecting one of the 50 stores at random, then surveying each employee at that store, there could be like a conflict with the store, because you're choosing all the employees from this particular store, so it's not as random, and this particular store might just have bad employee satisfaction, so you may get bad results, but that doesn't mean for the holistic scores. So for this question, the most effective answer would be B, selecting 10 employees from each store at random and then surveying each employee, because you are choosing 10 employees from random stores, so you're getting a more widespread answer, and when you're surveying each of the employees, they can have different experiences, so you'll get your reached answer. The next question is, the two graphs above show the total amounts of money that Ian and Jeremy each have deposited into their savings account for the first 7 weeks after opening their accounts. After they made their initial deposits, how much more did Ian deposit each week than Jeremy? So first of all, looking at this graph, we can see that Ian started with $100 and Jeremy started off with $300. So obviously Jeremy starts out ahead with money. And by the first week, we see that Ian has increased his deposit by $100. So we can see that each week Ian is depositing $100 more into his savings. So there's a constant increase in growth by 100. So that means our slope is 100, because each week it's growing by $100. So our slope for Ian is 100. Now, as we look on to Jeremy, we see that he starts with 300, which is, once again, that's more than what Ian started with. And let's just write this down. And as he moves on to week 2, we see that he only deposited $50 more into his savings account, as the point is between 300 and 400. So by week 1, Jeremy is at 350, and by the next week he and deposited another $50. As we can see, it's grown to $400 by week 2. So since each week Jeremy's deposit is growing by 50, his slope is going to be 50. So now we can just subtract the slopes from each other. So Ian with 100 minus Jeremy with a 50. 100 minus 50 is obviously just 50. So how much more did Ian deposit each week than Jeremy? The answer is C, which is 50. For our next problem, we have a researcher surveyed a random sample of students from a large university about how often they see movies. Using the sample data, the researcher estimated that 23% of the students in the population saw a movie at least once per month. The margin of error for this estimation is 4%. Which of the following is the most appropriate conclusion about all students at the university based on the given estimate and margin of error? And our options are A, it is unlikely that less than 23% of the students see a movie at least once per month. B, at least 23%, but no more than 25% of the students see a movie at least once per month. C, the researcher is between 19% and 27% sure that most students see a movie at least once per month. And D, it is plausible that the percentage of students who see a movie at least once per month is between 19% and 27%. So for this problem, it's fairly simple. We see that the researcher estimated that, let's highlight this, or underline, 23% of students in the population saw a movie at least once per month, and the margin of error for this estimation is 4%. So this is all we need. So this creates an interval that the possible percentage of students who see a movie at least once per month would be 23%. Plus or minus the 4%, which is the margin of error. So let's do 23% plus 4% is obviously 27%, and 23% minus 4% is 19%. So, looking at the options, we see that option D, it is plausible that the percentage of students who see a movie at least once per month is between 19 and 27, and those fit with our results. So our answer is D. For our next problem, we see a book was on sale for 40% off its original price. If the sale price of the book was $18, what was the original price of the book? Assume there is no sales tax. So we have A, $7.20, B, $10.80, C, $30, and D, $45. So first of all, we notice that the book was on sale for 40% off the original price, and the book is now $18. So if the book was on sale for 40% off the original price, we're taking the rest of the percent of the book to be 18. So that would be 100% minus the 40%, which is 60%. So $18 is the 60% of the original price. So if we were to write an equation for this, we would write since we know that the $18 is the 60%, we can write 60% x, or x equals the $80 $18, or we could just write this as 0.6x equals 18. And now to solve for x, we would just have to divide both sides by 0.6, and by calculating this, you could use a calculator if you would like, because it's a calculator section. However, it's fairly simple. So 18 divided by 0.6 is 30. So the answer is $30. And looking at our answer options, that would be C, $30. Thank you for watching my video about solving SAT math problems in the calculator section. I hope you enjoyed.